Hi, this is Module 4. Today we're going to be talking about relative risks and odds ratios. These are two terms in epidemiology that are very important when estimating the risk of some outcome occurring. So we've mentioned the term risk factor a little bit. Another term that might be used interchangeably with risk factor is exposure. This is some variable that may or may not increase the risk of some outcome. Usually in epidemiology, the outcome is a disease, but it doesn't have to be. So for instance, if the question is, does folate deficiency increase risk of neural tube defects? This is a birth defect that can occur. The risk factor is folate deficiency. The outcome is neural tube defects. Or does physical activity decrease risk of breast cancer? The exposure or the risk factor in this scenario would be physical activity. The outcome would be breast cancer. Does playing piano increase math skills? The risk factor or the exposure is playing the piano. The outcome is math skills. So you can see in all of these situations, we can ask a question. We want to know if some factor affects some other factor or outcome. And so in order to quantitatively evaluate the effect of a risk factor, we can calculate some outcomes, and that's what we're going to be talking about today, odds ratios and relative risk. So we want to know if some exposure is related to some outcome. In order to quantify that, we have to have data from an exposed group and an unexposed group. So if your exposure is folate deficiency, we have to know something about a group that has folate deficiency, and we have to compare it to a group that is not folate deficient. Or in the second example, if we want to know about physical activity and breast cancer, we have to have data from a group that's physically active and a group that's not. We have to be able to compare. So what we're going to talk about today is quantifying the association or the relationship between an exposure and an outcome. So as I mentioned previously, we have to have some comparison. We have to have a comparison of a group that has the risk factor and a group that does not. Comparison is really the basis for all of this field of epidemiology. So we're going to talk about actually three different calculations: risk difference, risk ratio, and odds ratios today. Okay, so if you like math, you're going to like this. If you don't, it's very simple, so you'll still be fine. But this is from your textbook, and this is called a 2x2 table. What this does is it allows for the calculation or the quantification of how much risk goes along with a risk factor. So what you have is here on the left-hand side, or the far left column, the risk factor status. Either is the risk factor present or is it absent? So for physical activity, if present would be someone's physically active, absent would be inactive. Or for for folate deficiency, the risk factor present would be the deficiency, absent would be no deficiency, and so on. And then across, under disease status, you have present or absent. So do they have the disease or not? So if we go back to the physical activity in breast cancer, the disease is breast cancer. So under present, it would be the people in the study who do have breast cancer, and absent would be those who do not. So you can see that every person or every subject in your sample that you're studying would fall into one of these categories. If there are 10 smokers with lung cancer in your study, A would be the number 10, and say there are 20 smokers who don't have lung cancer in your study, B would be equivalent to 20, and so on and so forth. And so you can see how you might be able to calculate some different outcomes, like the total number of individuals with the risk factor present would be A plus B, or the total individuals with the risk factor absent would be C plus D, and so on and so forth. Previous slide, which was develops the disease or does not develop. And so you can't calculate incidence truly with a case control study design, because incidence involves the development of new cases, which you don't actually have in a case control study, because it's not a prospective looking forward. But really these are kind of semantics. The calculations really work the same way. So again, remember, we're going to be calculating 3 different measures of comparison. Comparison is what we're interested in epidemiology. So we're going to talk today about risk ratios, risk differences, and odds ratios. So let's start with risk difference. This is really the most simplistic. It's just a difference between 2 risks. So I'm going to abbreviate it RD, and it is the risk in the exposed group minus the risk in the unexposed group. Remember, epidemiology is comparison, so you're comparing risk in one group to another. In this case, you're comparing risk in the group that's exposed to whatever risk factor you're studying versus unexposed. So back to the folate deficiency example, compare the risk in the group that's deficient minus the risk in the group that's not deficient. So, for example, the risk of whatever outcome, we'll say folate deficiency, say it's 5% in those exposed, it would be the risk of neural tube defects is 5% in those exposed to folate deficiency, 4% in those unexposed. So in this case, the risk difference would be 5 minus 4, so it would be a 1% difference. So it's really just a very simple subtraction. Here's another example. Let's say that the risk of lung cancer is 20% in heavy smokers and 1% in people who have never smoked. So in this case, the risk difference would be 20 minus 1, or 19. And then lastly, say that the risk of appendicitis in people who eat popcorn is 4%, and it's 4% in people who don't eat popcorn. The risk difference in that scenario would be 0, 4 minus 4. There's no association. That means that appendicitis is not related to popcorn consumption. Okay, now let's look at risk difference with the 2x2 table. Remember, the formula for risk difference is the risk in the exposed minus the risk in the unexposed. Simple, just a difference between 2 numbers. Another way to see this formula, though, if you have a 2x2 table, is A over A plus B. So that would be A here, 400, divided by 400 plus 5600, and minus C over C plus D. So C is 100, that's the people who develop the disease but do not have the risk factor, and then C plus D would be 100 plus 3900. So if we do that math, you walk through all the steps, you come up with 6.7 minus 2.5. So it's basically just the difference in the incidence rates. It's a lot of math to get you to this point of taking 6.7, the incidence rate in the sedentary people, minus the incidence rate in the active people. So I know that looks like a complicated bunch of math and the formula is a little confusing, but really it's just a difference in 2 incidence rates. So in this situation, 6.7 minus 2.5, you've got a risk difference of 4.2%. What this means is that there's a higher risk of, in this case, coronary heart disease is the outcome. There's a higher risk of coronary heart disease if you're sedentary compared to being active. I want you to think of risk difference as attributable risk. This is the amount of risk that you can attribute to some risk factor. So here's an example. People who eat hot dogs have a 10% risk of toe cancer, while people who do not eat hot dogs have a 4% risk of toe cancer. Yes, it's a ridiculous example, but it doesn't really matter. What does that mean about your risk factor, consuming hot dogs? It means that the risk difference would be 10 minus 4, 6%. This means that you can attribute 6% of the risk of toe cancer to eating hot dogs. Or another way to say that would be that if all people stopped eating hot dogs, 6% of toe cancer cases would be eliminated. Okay, so it's not the sole cause of toe cancer, but 6% of toe cancer cases would no longer exist if no one ate hot dogs. What this also means is that 94% of the risk of toe cancer comes from something else. We don't know what it is. It doesn't matter what it is, but 94% of the cases come from some other thing. Ultimately, it's up to the consumer to decide if that risk is worth it. Do they enjoy eating hot dogs enough to take the risk of toe cancer? That is up to the. Okay, so now let's talk about relative risk. Sometimes this is called risk ratio. It means the same thing. You're going to see it abbreviated as RR, and it is simply a ratio of risk in the exposed group to the unexposed group. So instead of subtracting, now you're dividing. That's really all it is. If the risk in both groups is exactly the same, you'd get a relative risk of 1. If you have a relative risk of 2, this means that there's twice the risk of disease in the exposed compared to the unexposed. So say for smoking and lung cancer, you had a relative risk of 2. That means smokers are twice as likely to get lung cancer as are non-smokers. Say you had a relative risk of 1.6. That means that you're 1.6 times more likely to get the disease if you're exposed compared to unexposed. Or another way to say that is you have a 60% increased risk. What if you have a relative risk less than 1? Let's say it's 0.5. What this means is that you have a 0.5 times or half the risk of disease. So let's say that physical activity and breast cancer, there's a relative risk of 0.5. That means that people who are physically active are half as likely to get breast cancer as those who are not physically active. That's how you would interpret this number. Now let's talk about how to calculate it. Here's your 2x2 table. The formula is here on your screen. A over A plus B over C plus D. Or another way to think about it is just the cumulative incidence in the exposed divided by the cumulative incidence in the unexposed. So if you use the A over A plus B formula, you do 400 divided by 400 plus 5600 divided by 100 over 100 plus 3900. All of that math comes out to 6.7 divided by 2.5. So again, just like you saw the incidence, the risk difference with this same example, subtracting the incidence for sedentary versus minus the incidence for active, here you're just dividing those same numbers instead of subtracting them. So the relative risk is 2.68. So what this means is people who are sedentary or who have the risk factor are 2.68 times more likely to develop coronary heart disease than those who are active. Okay, here's another example. This data is from the Nurses Health Study. This is a cohort study. Again, a cohort study is when you take a group of people, follow them over a period of time. So in this particular study, they studied nurses, and then they were enrolled in the study, were followed over many years, and watched for development of hypertension, cardiovascular disease, and so forth. So this is a 2x2 table. You see on the left column hypertension, which is high blood pressure. Yes, either they have hypertension or no, they do not. And then the outcome is a non-fatal heart attack, either yes or no. So if we want to calculate relative risk, remember the formula is the cumulative incidence in the exposed divided by the cumulative incidence in the unexposed, or A over A plus B over C plus D. So I'll let you work through all of the math on your own, but if you go through that, you come up with a relative risk of 7.5. So what that means is that women in the Nurses' Health Study who had hypertension were 7.5 times more likely to have a non-fatal heart attack than those who didn't have hypertension. Or another way to say it is hypertension appears to be a risk factor for a non-fatal heart attack. I think the answer is how common these conditions are. So look at the incidence. Smokers, 140 smokers per 100,000 got lung cancer, and 669 got coronary heart disease. 10 non-smokers got lung cancer, and 413 got coronary heart disease. The reason here is that coronary heart disease is so much more common than lung cancer. So especially with conditions that are very common, it can be important to, if you're interested in, at the population level, eliminating morbidity or mortality from a certain condition, you want to look at the risk difference, not just the relative risk. I'm sorry. That means that daily bathing reduces the odds of head lice by 1 minus 0.37, or 63% reduced risk. So again, even though the calculation for relative risk and odds ratio is a little bit different, the interpretation is identical. A relative risk or an odds of 1 means no added or reduced risk. The risks are equal. An odds of 2 means twice the risk. What if the odds was 5.72? That would be a 5.72 times greater risk. If the odds was 0.62, you take 1 minus 0.62 to get a percent change, so that would be a 38% decreased risk, and so forth. One more thing that I want to mention is that you'll often see confidence intervals with relative risks or odds ratios. This can be a little confusing because it's abbreviated CI, just like cumulative incidence. But as you see on the second bullet point on the screen, odds ratios, it will almost always be set up this way. It will say OR or RR equals the odds ratio, then we'll have a parentheses with a range. The two numbers in the parentheses, that's the confidence interval. It's an interval of two numbers. What these mean is that it's a measure of the confidence or the degree of surety that the observed relative risk or odds is truly meaningful. Basically, what it does is a calculation of if the study were repeated 100 times, you would get a number between this, somewhere that falls in this range or this interval, 95 of those 100 times. So in the example in the second bullet point, if I did the same study 100 times, the one time I did it, I got an odds of 2.4, but if I did it 100 times, 95% of that time I would get an odds between 2 and 2.8. So that's great. Who cares? What does this mean? Confidence intervals are used to decide if the risk or odds is statistically different from 1. So remember, if you have a relative risk or an odds of 1, that means there's no effect of your risk factor. So let's say the odds of developing flu is 1.3 for those who live in dorms compared to those who live off campus, but the confidence interval is 0.9 to 1.7. Great, what does that mean? So if you repeated your study 100 times, 95% of those times you'd get an odds of somewhere between 0.9 and 1.7. But this confidence interval, 0.9 to 1.7, includes 1. That means that we cannot be confident that those living in the dorms actually truly have a higher odds of flu. So what you're looking for is, does the confidence interval include 1 or 0? If it does, you cannot be confident that your odds or your risk is really different from 1. Today, quiz 2 is due, and I hope you have a great weekend.